Thank you very much. So our next speaker is going to be John Evans. John Evans is also visiting from California. He's a professor of sociology at the University of California, San Diego, and his research focuses on the sociology of bioethics and the sociology of religion and science.
Thank you very much. I'm losing critical time here. Okay. I'm a sociologist, and I examine public debates about biotechnology. The public should have input into debates like this, but public bioethics in general has no mechanism to do so. I have previously written that when making bioethical recommendations to government entities, the public's general values should be used as input, and then a committee like this should use its ethical and scientific expertise to determine whether the technology is ethical in light of the public's values. Of course, people are free to argue that the public's values are wrong. But therefore, in my comments, I'll try to channel the public's general values that I've learned from various social science research projects over the years. Let me give three general values of the public regarding humans and biotechnology. First, the public is not negative about medical or scientific technology per se. They're concerned with what you're going to use it for. So the details of this technology probably do not morally matter, but the details of what you're going to do with it do matter. The exception to this, of course, is the 20% of the public, more or less, that is opposed to destroying embryos for any reason. This is a well-known position within Catholicism and evangelical Protestantism, and others can speak to that better than I. But obviously, since a good portion of the public thinks this way, it has to be considered. Secondly, the general public puts a very high value on the relief of suffering caused by disease. People will often endorse science fiction type technologies to heal diseases, even if it seemingly violates other ethical stances that they hold. Third, people believe in manipulating nature for human betterment, but not manipulating the human species itself. People do not want humans to control the features of the human species, but whether want to do what's natural, quote unquote, or what God wants them to do. So when it comes to the design of humans, the public advocates the naturalistic fallacy. The reason they want the species to be natural is that in Western culture has long made a distinction between the creation of humans who are seen as special compared to animals and the rest of nature that can be controlled by humans. And there's Enlightenment-based secular translations of that idea as well. More specifically, they want the human genome to be set by some force outside of human control, like nature or God. For many Christians, humans could in principle use our God-given brains to modify the human genome, but only if we knew what God wanted us to do. Not knowing exactly what God wants, the solution has been to leave the entire thing alone. In general, for the public, humans lack the wisdom of God and or nature and are prone to use technology to further their interests or create social hierarchies. But if the quality of the human species are set by God or by nature, this will not have negative social influence. Now, needless to say, the second and third things I just said conflict with each other in the case of mitochondrial transfer, and that's one of the tasks before you. I will focus on the historical moral divides in academic debates about genetic engineering in humans, why the divides exist, the arguments made on their behalf, and whether the contemporary public values still support these distinctions. In the beginning of the academic debate in the 50s and 60s, there was none of the moral distinctions we see today. Human genetic modification was being promoted by reform eugenicists who wanted to improve the species. They were reform eugenicists because they did not want to select the best races or classes or engage in coercion, but rather pick the best genes from whatever race or class and get people to voluntarily produce more people with these preferred genes. They wanted the species to have less disease, improve its intelligence, musical ability, capacity for virtue, and so on. Opponents of this in the 1960s were concerned that people with power would write their own values into the species itself. The religious opponents cited C.S. Lewis to the effect that the power over nature was the power over other humans. The secular and religious people both cited the Brave New World as a case where the values of efficiency and order had been designed into the species to our detriment. So whether or not to engage in germline human genetic engineering was the original debate from which emerged these other distinctions referred to in the session objectives for this conference. In about 1970, younger scientists became quite concerned that the older generation of eugenicist scientists were scaring the public with utopian visions of designing the perfect species. They advocated the moral divides to distinguish their work from the eugenicists. They were somatic modifications limited to changes that would die with the person, and the germline that would be passed on. There were diseases that the younger scientists wanted to heal, and enhancements that had been the goal of the older eugenicists. The system worked as a sort of detente Scientists only wanted to do what was in cell 1 anyway, and this would become redefined essentially as medical research, and it was advocated by Bernard Davis. Ramsey was an opponent at the time, but agrees to this, later on taken up by the RAC. Let me use this slide to make a conceptual point. Many people are concerned about the slippery slope. Slippery slope arguments may not always work philosophically, but a probabilistic version of the slippery slope exists in policy, and it's how public views actually change. The legitimacy of a slippery slope argument is then based on whether you want to avoid the bottom of the slope at all, and the odds that engaging in some act will cognitively take down one of the walls that block the slippery slide down the slope. So in these debates, cell 4 has always been the bottom of the slope, and the lines in this figure are the existing walls on the slippery slope that arrest the slide. Most everyone in this debate, up until the mid-90s, cited cell 4 as that which we will not do, that only the eugenicists had been interested in. However, there is a new generation of scholars arguing for cell 4, and therefore the slippery slope would not be relevant to them. This is a long-standing framework, and if we assume, as people talked about today, that we assume that people have a reproductive right, then therefore mitochondrial transfer would belong in cell 2. The somatic germline distinction has held up all these years because it reflects something very deep in the views of the American public, which is the difference between repair and creating. There are religious versions of this, there are secular versions of this, like the story of Frankenstein. The public has definitely gotten used to technologies like IVF, but since their concerns are not about technology itself, but what you're going to do with it, I do not see the cultural support for this moral distinction having declined in the past 40 years or so. The idea continues through laws banning germline modifications in a number of other countries. The Nuffield Council in Britain claims that people would recognize a moral distinction between nuclear and mitochondrial DNA, moving the wall on the slippery slope over, putting this technology in cell 2A. Since the public is concerned with your goal, I don't think it matters where inside the cell the DNA is. Both mitochondrial and nuclear DNA influence bodily function, so I don't see how this distinction is going to make any traction in the public at all. The other long-standing wall on the slippery slope into cell 4 was the moral distinction between restoring health versus enhancement, which I represent in red here. Mitochondrial transfer is in the restoring normal health category because mitochondrial disease is not normal. This was a durable distinction because it fit with this public desire for objectivity and not having society decide what was a good or bad gene. Normal was what existed independent of what people thought about it, and thus normal would fit with what God or nature had wanted for the human body. But the normality standard, or this distinction, broke down by the late 90s, with bioethicists saying that relying on normality would still allow a lot of suffering to occur, and what was normal was also unclear, as has been mentioned previously. The line was redefined from normality to that which relieves the suffering of disease. It's not normal for humans to be genetically immune to cancer, but if you could do it, it would relieve suffering and fit into this new allowable category. This new distinction emphasizes the relief suffering value of the public, but underemphasizes the non-human control aspect. I've read that there's an influential scientist advocating the use of mitochondrial transfer to avoid infertility caused by aging eggs. This does not fit into the old normality category because the aging of eggs is normal, but it fits into the new category because it's relieving the psychological suffering of women who want to have a baby that's genetically related to them. The fact that people are already suggesting this new use suggests how slippery the slippery slope ends up being. I think it needs to be acknowledged that this technology crosses another moral line that hasn't been discussed and might not make sense in bioethical discourse, but I think it would be morally relevant for the public, and it's having to do with the third parent. The third parent, in my opinion, does not result in any social or identity effects for the resulting child that I can see. I agree with people who've said that so far. However, the third parent challenges this public urge to not control the genome, to have humans be natural or God-given. For the first time, it creates an overall genetic inheritance that was not possible the quote-unquote natural way. To understand this further, compare it to pre-implantation genetic diagnosis, PGD. I think the reason PGD is not that controversial is that any baby that's produced could have been born the old-fashioned way. PGD is just improving the odds of getting a child without disease. It is helping nature. If you do not focus on the high technology technique of PGD, which I don't think the public is particularly fixated on, PGD is just selecting among natural, quote-unquote, possibilities. But while the public would perceive the technology itself of mitochondrial transfer and PGD to be more or less morally the same, in my opinion, the mitochondrial transfer embryo could not have happened natural, and is clearly of human design. I'm not saying that you shouldn't cross this line. I'm just saying if you do so, you should do so consciously. So in conclusion, these are the morally relevant lines as defined by bioethical debate over time, and how these lines relate to what research, social science research says the public's values are. I think your recommendation will be based on weighing the desire of people with mitochondrial disease who want to have children that are genetically related to them with the importance of these divides. Thank you very much.